All right, when we're simplifying a problem like part A, the first thing that we want to do is simplify that fraction inside the radical. So I'm going to go ahead and do that first. First, we focus on our numbers. We have a 16 in the numerator and a 2 in the denominator. We can cancel 2 out of both of those. Gives us 8 in our numerator. And then I turn my attention from the numbers to the first variable, which is x. I have an x to the fourth in the numerator and an x in the denominator. Can cancel an x out of both of those. Leaves me with an x to the third in the numerator. And then I'm going to turn my attention to the z's. And all I have is a z to the third in the denominator, so there's nothing that I can do with that. I just leave a z to the third in the denominator. Now, in this next step, I'm pretty much just thinking. We're trying to take the third root of this fraction, and when we take a third root, anytime we have 3 of a particular factor that shows up inside the radical, we can take one of them out of the radical. So, what I'm thinking is what the actual factorizations are of the numerator and the denominator here. Now, 8x to the third, 8 is 2 times 2 times 2, and x to the third is x times x times x. And then in the denominator, z to the third is z times z times z. And anytime I have a group of 3 of the same factor, since this is a third root, I can take any group of 3 and bring one of them outside of the radical. So here I have a group of 3 2's. I can bring a 2 outside of the radical. Here I have a group of 3 x's. I can bring an x out of the radical. And then in my denominator, I have a group of 3 z's. And so I can bring one of them out of the radical. There's nothing left inside the radical, so I don't need the radical sign anymore. And I'm at my final answer, 2x over z. All right, let's turn our attention to b. Again, I'm going to take the same approach to begin with. I'm going to simplify this fraction inside the radical as much as I can. 176 divided by 4 gives me 44 in the numerator. And then x's, let's see, I've got an x to the 6th in the numerator, no x's in the denominator, so I still have an x to the 6th in the numerator. Y's, I have a y to the 7th in the numerator and a y to the 3rd in the denominator. Cancel a y to the 3rd out of both of those. Gives me a y to the 4th in the numerator. And now again, I'm back to that thinking step. This is a square root, which if you remember means the second root. And so I'm looking for groups of factors in 2's. I'm going to completely break down 44 into its prime factorization. That's 2 times 2 times 11. And then the x's, there are 6 of them. Again, I probably would not write all of this out, but this might make it a little easier for us to see, at least when we're first gaining a lot of experience with these. And now I'm going to pick out factors in groups of 2. There's a group of 2 2's, so I'll bring a 2 out of the radical. There's a lonely 11, so that guy's going to be left alone. There's a pair of x's. There's another pair of x's. There's another pair of x's. Then I've got a pair of y's and a pair of y's. And now I've taken care of all the factors in there, but there's that lonely 11 still inside the radical. So we're going to leave that inside the radical. And now I'm going to recombine the terms outside of the radical, and I get 2x to the 3rd y squared times the square root of 11. And I'm done.